So problem number 1 in section 5.2 starts us off with asking what is the factored form of this polynomial. We did factoring. We did a ton of factoring, probably to the point that you were sick of factoring. What do we always want to look for as our first step in factoring? We want to look to see if there's a what, Andy?
Common factor.
Exactly. Is there a common factor here in this x cubed minus 2x squared minus 15x? There is. It's an x. So you want to first factor out the GCF, which is x. And then we have x squared minus 2x minus 15. First, factor out your GCF, and then check what's in parentheses and see if it can be factored further. We've got a trinomial coefficient of 1 here on x squared. So this is just the basic kind of factoring that we went over very first in our factoring section. Factors of 15 that will give you -2, -5, and +3. How could we check to make sure that's our correct answer? Steve? Yeah. You could just do what we just did in reverse. If we took this and we multiplied x times x minus 5 times x plus 3, I'm going to, it really doesn't matter because it's multiplication, so it doesn't matter which order you multiply in. I'm going to FOIL first. I'm going to multiply these two first just because that's what I want to do. So I have x. I'm not doing anything with this x yet, but I'm going to multiply x minus 5 times x plus 3, giving me x squared plus 3x minus 5x minus 15. And I can simplify that. And then I would multiply this x back in to get x cubed minus 2x squared minus 15x. Sure enough, that's where we came from. So if it ever tells you to check by multiplying, all you do is you take your factored form, you remultiply it. Make sure you got the same thing. Notice we have 3 x's here in our answer. This came from a cubic polynomial. X to the third gave us 3 x's here in our factored form. What's factored form of x cubed minus x squared minus 12x? Again, look for your common factor first. You're going to see your common factor is x. Then just focus on what's in the parentheses. Factor what's inside of there. I need factors of 12 that would give me -1, so that would be -4 and +3. So that would be my factored form of the polynomial. On the bottom of that slide there, it's talking about something we've kind of talked about before. The fact that roots, zeros, x-intercepts, solutions, they are all interchangeable words that say find the answer of your polynomial. Find the x values of your polynomial. All of those words can be used interchangeably. Linear factor, zero, root, x-intercept, solution. All of those words are meaning, what is the answer here? Where does my graph cross the x-axis at? So that's all that slide is saying. So now what we're going to do is we're going to take this idea of, okay, if I factor, then I can get my x-intercepts. If I have my x-intercepts, I can use what I already know from 5.1 to graph these. So we have factored form here. In problem 2, it's telling us to find the zeros, and then it's telling us to graph this. Well, they were nice enough to already factor it for us. Notice we have y equals x plus 2, x minus 1, x minus 3. So that's already in factored form. We don't need to do the factoring. But we do need to find the zeros. The first step here, what are the zeros? How do we find zeros from a factored form like this? What did we do? After we factored, how did we find what the solutions were? Chelsea? Right. Do you guys remember when we did this? And we would say x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. So that gives us the zeros of x equals negative 2, x equals positive 1, x equals positive 3. So that's what we want to do first if we're going to try to graph here. First, find your zeros. Now, if I were to graph this function, all I know right now are the x-intercepts. That's what the zeros are. They're the x-intercepts. So right now, my graph is going to look pretty boring because all I can do is say, I have a point at negative 2, I have a point at positive 1, and I have a point at positive 3. But I don't know what happens in between there. So we need to do two things. We need to think back to section 5.1, and we're also going to make a table of values. Thinking about section 5.1, I want you guys to think about what kind of polynomial did this come from? What kind of polynomial did this factored form come from? Quadratic, cubic, quartic, quintic? What kind? Andy?
Cubic.
How did you know it came from a cubic?
There were 3 x's.
Exactly. And that's why we pointed that out in the problem we just did. We've got 3 zeros. That means this came from a cubic function. So, knowing this came from a cubic, kind of put that in your mind here, this came from a cubic, this is how I know my end behavior is either going to be down, up, or up, down. Do you guys remember that from cubics? Your end behavior is either going to be down, up, or up, down. Think about what you came from here. It kind of changed the positioning a little bit, but it was x plus 2 times x minus 1 times x minus 3. That's going to be a cubic. Is that x cubed function going to have a positive or negative coefficient? Connor? Right. There's no negative sign here on the x's. So we know if we would multiply this the whole way back through, we're going to have a cubic. So it would be cubic. And it would have a positive x cubed value. Now your question's not asking for this. I'm just kind of throwing this in here for you guys to figure out where all of this is coming from. So we know our x's. Here they are. We know this is a cubic with a positive x cubed, meaning our end behavior is going to be what? Do you guys remember? If it's a positive value. Andy?
Down, up.
Down, up. So we're going to start down, and then we're going to go up. But how exactly do we do this? Is this a big high graph? Is it just a little skinny graph? Well, that's what takes us to our next part. We need to make a table of values. What you want to do is you want to choose x values between the x's you already know. We already know the 0, so we want to pick numbers that are in between them, such as -1, 0, or 2. So let's try 0. If x is 0, what is my y value going to be? What you need to do is you need to go back to the original polynomial that was given and plug in 0. 0 plus 2, 0 minus 1, 0 minus 3. Choose an x between your intercepts, plug it into the original. So this is 2 times -1 times -3. That's a positive 6. So now we have another ordered pair, 0, 6. Now let's try in between our other two x-intercepts. The only option we have, as long as we don't want to use a decimal, which we don't, that would just make things harder. The only other option we have to choose between the second 2 points would be the value of 2. So plug in 2 for x and find out what you get for y. And you should get the value -4. So now we have another point, 2, -4. And now it's like connect the dots. Think about what the end behavior is. We know the end behavior is down, up. So we start down, and then we go up, hitting all of our points. And you have just graphed yourself a cubic function. Pat each other on the back. Okay, so let's try another one. What are the zeros? Graph the function. Start off, what are the zeros? The question is telling you where to start. Who can tell me what the zeros are of this? There's 3 of them. Ryan.
X equals -5, x equals 3, and x equals 0.
Good. We know this came from a cubic because we have 3 x's. All of the x's are positive, so we know this is going to be a cubic with a positive leading coefficient. So we're looking at the same thing, a down, up, end behavior. Once you plot your x's, now we need other points to know exactly how high and how low to make the turning points. So that's where we bring in our table of values. Now for this problem, you're going to see you've got more options. We could choose anything between 0 and -5 here. So you have more options, and it's not going to work out quite as nicely as the other one did, where we just have small numbers like 5, 6, 4, those kind of numbers. They're going to get a little bigger, but that's okay. You guys can still graph these. So let's choose a number between 0 and -5. You guys choose, because it doesn't matter. Somebody give me a number between 0 and -5. Which one do you want to use, Ryan? -3? Okay. So now when we plug this in, we have, remember, your x is coming from x times x minus 3 times x plus 5. Does everybody see how I did that? Is anybody a little bit lost there? Okay, now we've got our ordered pair, and this is what I mean. We have a y value of 32. That's a lot harder to graph than just 1 through 5. So what I'm going to do is I'm going to make my y-axis, yes?
Isn't it 36? Because 3 times 6 is 18, and 18 times 2 is 36.
36. Yes, it's 36. Thank you, Kitty.
You're welcome.
Oh, geez. I'm scribbling now. So what I'm going to do is, even though my x-axis is just by 1s, I'm going to make my y-axis by 2s. Because otherwise, we're going to be in the ceiling and in the floor trying to graph this. Same with on your homework. You're going to have to use a whole piece of paper just to graph this little problem. So I'm just going to count by 2s. Your homework for today